one final example of being able to use combinations to be able to predict probabilities, a real life example as to where sometimes they compute the odds for casino games, etc. Suppose there's, and for those of you that don't know, this game called Powerball. Powerball is a Maryland lottery game, and you can win a whole lot of money if you guess the right numbers. The highest prize ever paid out was $1.586 billion. Now that was paid over to, I think, several people. I think it was in 3 different people in 3 different states, but regardless, the fact is that people are multi-millionaires just as a fact of just gambling. And to play Powerball, basically, what you do is you just guess. There's 5 numbers that you guess, and the numbers range between 1 and 69. And what you have to do is you just have to pick, for different level prizes, you have to select the right numbers just by complete sheer luck. And there's also one Powerball number that's between 1 and 26. So essentially there's 2 different games going on. There's the 5 numbers that you pick, and then simultaneously there's the Powerball number. And there's different prizes, which we'll discuss at the end. But essentially, let's try to figure out the probability that people win the different levels. So the first one that we have, we want to find the probability that somebody selects one correct number and they select the Powerball number correctly as well. All right. So before we even do this, we want to think what it is that we actually have on hand. All right. So we just have the regular game, and I'm going to do that over here, where there are 69 numbers. All right. So 1 through 69. So n is equal to 16. And you have to select 5 numbers. Okay, so we would say that there are, I'm sorry, n wouldn't be equal to 16, it would be 69. Excuse me. So there's 69 possible numbers. Now we pick 5, right? So in essence, there's 5 numbers that we want. Okay, so there's 5 numbers that are good for us, which means that there are 64 that are bad numbers. All right, and those are the 2 groups that we want to think about: the good numbers and the bad numbers. All right, the bad ones are the ones that don't come up for us. The 5 are the good ones. There's also the other game, the Powerball game, or the Powerball selection. And really, with the Powerball, there's only one number that you can pick between 1 and 26. So there's a 1 in 26 chance that you're going to get the Powerball number correct. All right, so that one's pretty straightforward, but that's a different game. So let's see if we can figure out what the probability is that someone picks the correct number, or one number correctly, and then selects the Powerball game. Okay, so first of all, we need the total number of ways. And that's pretty easy. There are 69 possible numbers. And of those, we want 5. All right, so the total number of ways to pick is 69, choose 5. So let's go ahead and plug that in. And we're going to get a fairly large number, I'm assuming. So it looks like it's going to be somewhere 11,238,513. So 112,38513. All right, so now remember, this is just for the regular game. All right, so find the probability that, first of all, somebody selects one correct number. All right, so now there are 5 good numbers. We want 1. And that means that there are 64 bad numbers. And of the 5, we want 4 of those. All right, and then we're just going to divide that by 112,38. I think it was a 3. Yeah, that's a 3. So let me make it 38513. Right, now, we know what 51 is. 51 is 5. So we really just need 64 4. Right, so we're just going to, now here's what I'm going to do. I'm just going to hit second enter. I'm just going to back it up to make it 64 4. All right, so 635376. So 635576. And then we're going to divide that by 112385513. So let's see what we get out of that. So we're going to take 5. We're going to multiply it by that 635376. I think I copied that down wrong. So 635376. So that should be 3. And then we're still going to divide that out by the 112385513. All right. So now this is the probability that somebody picks one of the numbers out of 5. Right? So 0.282677. We'll just say 0.2827. So 283, I guess, if we're rounding that off. Right? So that's 0.283. However, that's not the probability of the question, because remember, that's just one correct number out of the 69, right? We still have to select the Powerball number correctly as well, right? So we're going to take that 0.283 that we just got, and then we're going to multiply that by 1 out of 26. Okay, so we're going to say, just take that answer, and we're going to multiply it by 1 out of 26. All right, so we get 0.0109. Now I'll go out, in fact, let's just keep this here, but we'll just say 0.0109 for right now, or 011. Right, so it's about a 1% chance, 1.1%. All right, now, what I did was I actually looked up the estimated probability of this. All right, so now this is the last item down here. Right? And if we take a look, so we want the Powerball, and we also want to match one of the other balls, and the probability of that is 1 in 92. So let's do this. Let's type 1 out of 92. And see if we get anything close. All right, and what you'll notice is that the numbers are extremely close to one another. And you might be asking, well, why is there a disparity? Well, if you look at what the Powerball says, it's the approximate probability. All right, so what we found was we found the empirical probability. This is an approximate probability because they just wanted to get it to the nicest integers if they could. So 1 out of 92, 1 out of 93. So they just kind of rounded it off to kind of meet those odds. All right, so this is how they're actually coming up with the odds, is they're just going right down the list right here, and they're doing these combinatorics, and that's how they do it for a lot of these lottery games. All right, now let's do the same thing for all the other ones, and let's see if we get numbers that are fairly close to what we thought, or to what these are. All right, so let's go back, and there's still 3 other questions that we have to answer. All right, so what's the probability that somebody selects 3 numbers and does not select the Powerball number correctly? All right, so to figure that out, so we want 5, 3, 64, 2. Right? And again, that's just because we want 2 of the bad numbers, because we want 3 exactly. And then we're going to divide it by the 112385513. So let's see how that goes. Right. So we're going to go in a calculator. We're going to do 5 combination 3. And that's 10. And we need 64 combination 2. All right. So 10 in 2016. Right, so that's going to be equal to 10 times 2016 divided by this 112385513. So let's see what happens when we divide this out. And so we're going to get 2016 times 10, which we know is 20160, divided by the 112, and I forgot what it was already, 38513. All right, and then we end up with a 0.00179. All right, so let's just kind of keep that on hold for right now. Now we go down, and we have 3 and no Powerball. All right, and somebody wins $7, and they're telling us the probability is 1 in 580. So let's plug that in. So 1 out of 580. All right, and there we go. All right, now it's just a little bit off. All right, and one thing that we should probably consider is that we take the previous answer, and we should probably multiply that by 9/10. Well, let's see what that does. All right, so if we do that, and 9/10, it doesn't really give us it actually gives us a little bit closer, or actually a little bit further. It's for the probability, but why 9/10? Well, I think the people that computed this did not factor in the fact that there are, I'm sorry, we should multiply it by 2526, excuse me, because they don't want the Powerball number, so not 9/10. So clear that out. So we're going to take that number, and instead of 9/10, let's multiply it by 25 out of 26. All right, let's see if that gets us any close to the 1 out of 580. All right, so it gives it to us almost exactly. All right, and you're probably asking yourself, well, why do we want to multiply it by 25 over 26? Where does that come from? All right, so let's go back up. Okay, now remember, 00197, this is the probability of drawing 3 balls. All right, but what we want is 3 of the white balls, which is the 0.00179, but we do not want to win the Powerball. And how do we figure that out? Well, that's 1 minus 1 out of 26, or that's 2526. So remember, in the Powerball number, so let's go all the way back up here. Remember, there's 1 Powerball number between 1 and 26. That means there's 25 numbers that are not the Powerball numbers. All right. So to get the answer that we really want for this is how they're coming up with it, is you're going to take that 0.00179 and you're going to multiply that by 25 over 26. And that gives us the real answer. All right, so that's the 0.00172. And we can just leave it at that. So 0.00172 should be the answer that we want. That's going to say, okay, well, we get the 3 balls, but we do not win the Powerball. All right, and that really is close to the 1 in 580 odds that were suggested before. All right, now for part C, this is part A, part B. For part C, we want to find the probability that somebody selects 3 correct numbers and selects the Powerball number correctly. All right, so they want to win $100. So well, remember, to get the 3 balls correctly, didn't we just figure that out? That was 0.00179. Okay, but what we're going to have to do is to win the Powerball, which is 1 out of 26, we're going to have to multiply these 2 numbers together. All right, so let's go back to our calculator. And I'm going to hit second enter, and I'm going to hit second enter again. All right, now, what does this do? So this is all this mess right here. So remember, we figured out 2016 times 10. All right, so 2016 was the number of ways to pick the incorrect numbers. There were 64, we wanted 2. There were 10 ways to pick there were 5 numbers that we wanted, and we want 3 of them, so that's 5 combination 3. This is the total number of ways. So that's already done for us. And then over here, instead of 25 out of 26, what I'm going to do is I'm just going to type in 1 out of 26. And that gives us this number. All right, we haven't seen anything like this before. So notice there's this e to the minus 5. So I'm going to copy that down. So it's 6.8994. I'm going to copy a lot of numbers really quickly. So when we multiply these together, we're going to get 6.8994. Right? And then we have this e to the minus 5. And I want to make sure everybody understands what that really is. This is really scientific notation. All right, so you might remember from basic algebra, what this really means is that we have 6.8994 times 10 to the minus 5th power. And that means that we're going to move the decimal point 5 places to the left. All right, so we're going to have 6.8994. We're going to move it 1, 2, 3, 4, 5 places to the left, and then we're going to fill in the zeros here. All right, so the probability of us winning $100 is really going to be this number right here. Okay, almost nothing. All right, so now let's go down and let's see whether or not this really does make sense. Okay, because we have our answer. So we're going to go down here. And notice that the probability is 1 in 14,494. So let's type that in. So 1 out of 14,494. And wouldn't you believe it? These numbers are almost the exact same. All right, so, and again, there's a little bit of rounding error because what the Maryland State Lottery does is they don't want to show you these numbers, the ones with the 6.89935. They don't want to show you the percentage. They'd rather show you 1 in 14,494 because that's a little bit easier to digest for most people. All right. So what you would have to do in essence is play that game 14,494 times, and then you'll win $100. Of course, that means you're spending about $29,000 to win that amount. So it's not very likely that that's going to happen. All right, now one last problem. All right, and this is probably the question you really want to know. All right, find the probability that somebody wins the Powerball jackpot, which means they must select all 5 numbers correctly and select the Powerball number correctly as well. So it says it has a $700,000 top prize for this. Now down here, it's just jackpot, but most of the time, that's what it ends up being. All right, so how are we going to figure that out? Well, here's how we do this. This one's actually, so there are 5 good numbers, and we need all 5 of them. There are 64 bad numbers, and we want none of them. And then, of course, we need our horrible denominator, which I keep forgetting, 11238,513. All right. And so we already know that 64,0 is 1. 5, 5. So if we go in our calculator, I know this is going to be 1, but let me just show you first of all that it is 1 because we've never done one like that. So 5, 5 is 1. So really you have a 1 in 11238, 573 or 513. Let me go back up and check just to make sure. 513. All right. Now remember what this is. All this tells us is the probability of selecting 5 balls correctly. We still need the Powerball, right? So let's go in the calculator, and we're just going to type 1 times 1 divided by that horrible number that I keep forgetting, 112. You probably remember it. 38513. All right, so now this is 8.89797, all right, and then e to the minus 8. But we're not done, because don't we have to multiply this by 1 out of 26? Because that's the probability of also getting the Powerball. All right, so 8.8979. So I'll just say 8.898. So this is approximately 8.898 times 10 to the minus 8th power. But then we have to multiply that by 1 out of 26. All right, so let's get a final answer for this. We're going to execute this, and that gives us 3.4223 times 10 to the minus 9, or yeah, 10 to the minus 9 power. So 3.4223 times 10 to the minus 9 power. And what does that really equate to us? Well, let me erase this so we have a little bit of room. And if that's our probability, boy, then that means we have the 3.4223, and we have to move the decimal point 9 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and we erase all this. We erase this decimal point over here. And so this is the probability that you are going to win Powerball. As a percentage, it looks so much better as a percent. So this would be as a percent. So you can see realistically that you almost have no chance of winning Powerball, at least the jackpot. Right? In fact, you have very little chance of winning $100. You have very little chance of winning $10 or $7 or whatever it is. Now, let's see if this makes any sense, because to win the jackpot, it says that this is the probability. All right, so let's stick that in our calculator, and let's see if we get anywhere close. All right, and if we did, then maybe we did it right. So 292,201. So 1 out of 292,021 or 201, 338. All right, and if I type that in correctly and check that out, this one is perfectly accurate. And the reason it's perfectly accurate is because there's only one possible way to win it. So they don't have to round it up to a nearest integer. This one's just like a perfect integer value. All right, so if you ever wanted to know how to compute your odds of winning a lottery or something like that, and they give you these numbers, now you know where the numbers come from. All right, so Powerball is actually a pretty cool example to utilize, but unfortunately it also gives you the realization that if you ever wanted to play it for real, you're very, very unlikely to win anything. All right, so hopefully this illustrates a real-life example as to where to go ahead and use these probability sorts of concepts.